All right, welcome to the lunchtime video. I want to keep this part really short. I just need to give myself a little bit of a talk. I didn't do any studying during the weekends, and I think that's going to be important. I did attempt to do some studying on Sunday, but I just wasn't feeling it at all. I kind of needed to de-stress and stuff, but really I'm only asking for an hour, 2 hours, which would give me a total of 4 hours on the weekend, and that's really going to be essential, I think, on the exam. The difference between passing and failing could be those extra, as little as 2 hours during the weekend, but hopefully just another 2 hours a day, so 4 hours during the weekend. That could be the difference between passing and failing. So I think that's really important, and I really don't think that's a lot to ask. All right, so let's continue with NG-MVPNs as was requested by a commenter. So kind of where, unfortunately, I can't go super into depth about this because there's just so much on the exam, but I think a great place to go if you're the commenter is this series. I won't be watching it just because it's really in depth. So for me, I just want to get the hands-on experience. Yes, concepts, not commands is kind of what I'm going for. But when you have literally probably less than 2 months to prepare for this exam, I just want to at least get through as much as I can and not devote too much time to any one topic. Maybe that's a bad strategy, but it's kind of the only thing I got. So Sunday I actually did do a little bit of work. So I think I'm still in the second video. I'm gonna verify that. But yeah, Sunday I got through like an hour of study, and then I just decided to give it up because I just wasn't feeling it, as I said. But that just might be because I started it later in the day. I really don't think it's going to be impossible to put those extra 4 hours in during the weekend. So YouTube leaves a lot to be desired because there's just so much distracting information. It's like, YouTube, you don't understand. I've got to pass this test. Okay, so let's see. So let's go to my studio here. And then we're going to go to my videos. Okay, and we'll see which is the last one. So, yep, sure enough, I am on 3 as I have listed here. So we're still doing this example. We've got that here. So I think, yeah, so I've got everything set up and good to go. So let's pull up the lab and continue working through that example. Okay, so here's the lab. So you can see I've got the topology changed. I've also got some basic configuration on there. I'm not going to be using ATM interfaces, so I saved myself a lot of work here. So let's go on and configure OSPF. On the P and PE routers, configure the provider instance of OSPF. Specify the LO0.0, and we won't need to do that. The provider instance of OSPF on the PE router forms adjacencies with the OSPF neighbors on the other PE router and router P. So we're going to have a separate, now remember, this is the customer network, and then this is the ISP network. So the customer network is going to have their own IGP. We're going to have OSPF, and then to communicate with each other, we're going to have special connections here that hopefully they will, it'll become more clear what those special configurations are as we work through this lab. And actually I was incorrect here. So this is the customer network here, because this is a CE customer edge. This is provider edge. So Now, one thing that's missing from this that I know from my experience in the ISP is this here doesn't show the whole picture. You'll also have you'll have just a layer 2 device, and that'll be what the ISP uses to, because on this, so let me take a screenshot here and mark this so it's more clear. So paint. Okay, so your internet service provider, this isn't all they're going to have. They're going to have this PE router in a location that they're either renting or that they own that can serve a lot of people. So let's say, let's open up a random map. Let's open it up to, I mean, the first place that comes to mind to me is Tulsa, Oklahoma, Tulsa, Oklahoma, but that'll be fine. Oh God, let's not look at Tulsa. Let's get the heck out of there. So what's a good place? How about what's a really interesting place? How about San Houston? Let's just go to Houston. Okay, this looks better. Favorite restaurants, downtown crowd. Well, that doesn't look so good, but hit and run doesn't look so good either. But I like restaurants, so let's go to Houston. Okay, so just to make it more clear what's going on and what's missing from this topology. So we got our topology here. So just to make it clear, the difference between here and here. So in the real world, what you're going to have is you're going to have locations that the ISP owns. So just at random, let's say that the ISP owns a building here. Now this is an internet service provider, so it could be to a residential area, it could be to businesses. So there's a bunch of businesses. Yeah, here there's Rainbow Lodge, restaurants, everything. So it's going to have the ISP is going to have a strategic location that can serve all of these, and then it's going to have, let's see here. Yeah, so this is just going to be one site, this CE. This is what we're representing. So T-Bone Sports Pub, that might be what this is. Then we're going to have, oops. There we go. Then we're going to have another CE off of this, and that might be Domino's Pizza. And then we're going to have another one, which might be Hughes, and then another one, which might be Rainbow. So at least this was my experience delivering fiber connections to businesses. So there is one piece of equipment that is missing between the CE and the PE, because these will all terminate in more CE routers. You're not going to have just one coming off of here. But in addition to that, you're going to have a box here. And then this is going to do things like regulate the QoS. It's going to monitor the connection to make sure if it goes down, link goes down, the ISP knows about it. A lot of people get really paranoid about like what the ISP can and can't see and stuff. So the ISP can see your MAC address, which they might be able to tell the kind of equipment you're looking by looking up the vendor code. And then, they have all the information that you provide them, your address and stuff, so that they can deliver the equipment to you. But as far as your traffic and stuff, there's really no reason for an ISP to look into that. And even the vendor codes, when I worked there, there's really no reason to even really be looking at that information, except to make sure that the connection is live. But as far as like harvesting data to see, which companies are using which equipment, I've never heard of anything like that. So these boxes here are just to give the ISP information about whether these links went down And if you've only got a certain amount of bandwidth you can deliver to all these customers, is to make sure that that bandwidth is regulated, because if you have just open pipes to all the customers, now this link here, oops, that's a square. Now this link here is going to get oversaturated. So you've got to regulate the amount of traffic going over this link by having these devices properly control the amount of bandwidth allocated to each customer, so that you don't get overflooded here. So this is why for example, I tried to order from AT&T recently, and they only had a 25 meg connection for me. It's like, oh, well, that sucks. Well, you know, they've got to regulate the uplinks, so that's all they had to provide for me. I couldn't get a higher link because they would likely oversaturate one of these if they provided that to me. So yeah, that's I just wanted to point that out, because this really gives an oversimplified view. And if you work at an ISP in the real world, you're going to see that they're leaving out an entire box here when they just do this. So it doesn't really give you an accurate picture of what's going on. And they'll have whole separate departments that can only work on these devices, and that can only work on these devices. So, you know, if you don't even know that these devices exist, you can be applying for a job there thinking you're going to work on these devices, but end up working on these devices. So it's important to understand kind of where you end up working, because you won't get hands-on experience with BGP, with NVPN, with that sort of stuff if you're working on these devices. The good news in my experience, though, is you can work on these devices. This is the kind of work I did primarily. So you can work on those like right out of networking school. My first job was at an ISP, and not only that, scripting efforts, that sort of things are safer here than here. So if you're working in a like DevOps, something like that. Now remember, I'm not saying specifically what is happening at the ISP I worked at. I'm just saying that a box like this is safer to automate than a box like this. So it's really important to know the full picture, especially if you want to work at an ISP, because you could end up thinking that you're working on these devices here, but then show up on the first day and be working these, and you didn't even know that those existed at all. So, and these are all layer 2. There's generally no routing on them. There can be sometimes, but in my experience, they've been layer 2. And then these have all the high-level stuff, BGP, VPNs, that sort of thing. But when I worked at ISP, I primarily focused on these devices. I did log in and look at these sorts of devices more a bit, but this was my main focus. All right, and I can't, obviously, I can't go into super detail on what I did. I didn't read the full report about what I can and can't say, but I'm definitely going to err on the side of saying too little than saying too much, if I can help it. Okay. Yeah, I don't think I said anything too much. Tried to keep it super general. And remember, I didn't say anything specific to my job. I just said things that might be reasonable to expect based on my experience in an ISP, not anything specific that not anything. Like, I didn't even say the ISP I worked at, and I won't say that on this channel. Okay, so let's go ahead and yeah, so let's continue with the example. All right, so the next step is configuring OSPF. It's kind of interesting. Oh, I see. So, so this makes sense. You can see that where I went wrong, I added both gigabit Ethernet interfaces, and you can see one's going to the CE, one's going here. So our ISP network is here, and then this is the customer network, and then of course it's missing that layer 2 device. So this is an enterprise networking setup here. So this is the kind of the main core router that reaches out to the ISP in an enterprise network, and that can be confusing. You might think that that device is in fact not represented on here, and it would be in like a cloud here, but nope, that's not the case. This is the enterprise core layer being represented here, and this is the edge of the ISP. So this link would not be configured into OSPF because it's kind of a demilitarized link between the customer and the service provider. These are the only links that are going to be added to the service provider IGP. Okay, and 0 is going to the left, 1 is going to the right, so it's just going to be GE001. Okay, so now loopback 0. So really nice and easy. Not many links need to be added at all. It's a pretty simple topology. I'm sure it's not going to be this simple on the exam. So P router, that's completely internal to the ISP, so we will need to add both links pointing to both sides on that. Okay, so one thing to notice that's really, really good. This actually might be on the test. They might say, it might be like a network security thing. They might say secure the management port, something like that. So that's what this is. This is the console ports on the Juniper. So function like standard management interfaces. So it's not, I don't think it's console, but it's an out of band management interface. So you wouldn't want this to be wide open necessarily, especially in an environment where security is one of your primary concerns. So this is a good, oh, well, it says to explicitly, to explicitly disable interface OSPF on that interface. So that's kind of interesting. I'm not exactly sure why they want that, but I'll just add it. No harm, no foul. I guess I want to do a quick Google search though. Oh, okay. So this is just if you have included interface all, then you're adding all interfaces, including the management. So you want to disable it. So if you get lazy and you have a lot of interfaces to add, as could be the case in the exam, sometimes it's more efficient to just add all the interfaces and then disable the ones you don't want to participate. But in this case where there's only 2 interfaces, I really don't agree with this. Maybe in the exam there's like 16, 20 interfaces to add, but I doubt that'd be the case. Yeah, I just really don't think this makes sense on a router, on a switch. It might, but I'm not planning to do that on the test because, as I've said before, they grade you on your end results and not your methods. Oh yeah, I'm really concerned about this test. The good news is on August 8th, they have a check-in with the official, her name is Yasmin. I have her blog bookmarked. So she's the official representative for the JNCIE-SP, and she has a question and answer session every once in a while. So I attended one of them, and I will be attending it again, and we'll see if there are any coronavirus specific questions and answers on August 8th. And I probably do need to be reading over this more because I have a feeling if the official representative for this test is blogging about something, it might be on the test. But for now, let's just continue with the plan. I think it's a decent plan to at least have covered the entire curriculum. All right. Because I have no idea what they're gonna throw at me, so I just want to be prepared for everything. And then it's a hands-on test, so hands-on practice makes sense to me. Hands-on practice for a hands-on exam. All right, so let's use the show interfaces command and verify that the neighborships have come up. And we can save ourselves a little bit of trouble by doing this on the P router, and then we can check both at the same time. Oops, so I guess I can't tell. So I do see this neighbor 0 here, so I don't think that's working. I think a better command than OSPF interface is OSPF neighbor. There we go. So now we can see there's a neighborship here on 1, but there's a problem with the one going to PE0. So let's do show configuration protocols OSPF. So everything looks good here. I think the problem might be on PE1. So of course the problem is definitely on PE1. So I wonder if what I did accidentally is I configured CE1 as if it were PE1. Yep, that's exactly what I did. So I think the IP addressing is fine. It's just these statements here need to be fixed. Okay, so hopefully the neighborship will come up now. And it happened instantly. I didn't even need that pipe refresh command. That's like my favorite command. It probably won't be available to me on the test, unfortunately, but because on the production Junipers I have experience on, I have spent plenty of time question marking for this command and haven't been able to find it. To the point where somebody asked me, what command are you looking for? I'm looking for my favorite one. Refresh, it's missing. All right. So on the CE routers, configure the customer interface of OSPF, specify the loopback and fast Ethernet logical interfaces, the customer instance of OSPF on the CE routers, form adjacencies with the neighbors within the VPN OSPF routing instance of OSPF on the PE routers. Okay, so we're going to form a OSPF adjacency to, this makes no sense at all. Why are they adding, oh, okay, so they do need to add two. It just confused me because they're not making one a passive interface. This you can make a passive interface in this topology, but in the actual production topology, you probably wouldn't want that one to be passive because you would want the updates to go through. So, yep, we're going to have a OSPF adjacency here. So let's set that up. Now, one thing that I am curious about is the PE routers, because we did not add the interfaces pointing to the CE routers, unless that's these. Nope. If it was these, we wouldn't be configuring the P router. Huh. Yeah, I don't know how they expect this to work. No, I do, because later we're going to be setting up the VPN configuration later, I think, and then, or not. Here we go. So yeah, this is where we're going to be making it so that those adjacencies come up. Right now, we're just doing some pre-config, but we won't be able to verify that it is proper until we finish configuring the L3 VPNs on the PE routers. Yeah, so all they want you to do is verify that the correct loopback and fast Ethernet logical interfaces have been added to the OSPF protocol. At this point, there's not going to be neighborships actually forming. All right, so let's do that. Okay, so in our topology, we can go ahead and make the interface GE000 that points to the host a passive, but that's not what it would be like in an actual one. So I think I'm just going to follow what is listed in the lab and not add that extra. And the only trade-off in doing that is that if we wanted to sniff that link, we'd get extra traffic that is not important, but it is just fine to have that. All right, time for CE2. Okay, and let's use that verification command. The more verification commands I can get comfortable with using, the better I will be prepared for the exam. And this makes sense because we're not going to have neighborships yet until we finish the L3 VPN configuration on the PE routers. So in my 961 video, I had what I thought were some really good explanations of VPNs. You can think of an ISP. You can think of these like houses, and then this is the front door of the house, and then this is the back door of the house. So you've got this as being a thing with entrance points and exit points. Really got to think of it that way because there's a difference between routes exchanged over a VPN and routes not exchanged over a VPN. So you really have got to have a good handle of where the routes are changed so that they're distributed with a route distinguisher versus where they are not. All right, so time to enable traffic engineering shortcuts. On the P and PE routers, configure OSPF traffic engineering support for the provider instance of OSPF. The shortcut statement enables the master instance of OSPF to use a label switched path as the next hop. Okay, let's take a look at that in maybe some closer detail. So configure traffic engineering attributes. Use label switch paths as next hop if possible. All right, time for the P router. Okay, so here's some new commands. So let's get comfortable using those. Show OSPF overview. So this is overview information of, or overview of OSPF information. We get all sorts of things. We get the router ID, we get the area, the stub type. So it's all here. This will be, I think, a pretty important command to know for the test because you get everything that is configured at a glance. You get the number of neighbors. You get to see whether this is enabled, which is important if you've got a MPLS LSP. All right, so let's look at the next one. So this is kind of more what I'm used to looking at. My tendency, I believe, is to kind of focus more on what's in the active configuration than what do my show commands tell me. Could be a weakness, could be a strength. I'm really not sure, but I do think there will be value in this command. All right, so on router P, configure BGP for the VPN. The local address is the local LO0.0 address. The neighbor addresses are the PE routers LO0.0 addresses. The unicast statement enables the router to use BGP to advertise network layer reachability information, NLRI. The signaling statement enables the router to use BGP as the signaling protocol for the VPN. All right, and we'll do an edit protocols BGP group MVPN, set type internal, set local address, set family, iNet unicast, unicast. Okay, and then set family iNet MVPN. So this is how it typically goes. If you want to set up some special kind of MVPN, some special kind of VRF, you need to specify that as a family. So you can see we've got it for VPN, we've got it for MVPN. We've got a special one. I'm not sure what that's all about. I don't think it's going to be on the test. So we've also got, of course, our IPv6, EVPN. So basically any special thing you want to use, you've got to call that out in the BGP protocols group configuration. Of course, it doesn't have to be to a group, but if it's not applied to a group, you won't have the ability to have multiple kinds of BGP connections, which is going to be essential on PE routers, potentially if you're connecting to the customer with BGP. In our case, we're using OSPF, but using groups, in my opinion, is a better way to configure things than just not using groups. I think there are limitations with not using groups. You have more, like using groups is a better way to configure BGP. Of course, there is some configuration because it inherits the other level configuration. So like this local address, if I want every group to use the local address, there's really no sense in just configuring it in every group. I can configure it to the uppermost level, edit protocols, BGP local address there. You can see that is valid. Oops. Yeah, so local address, and then it'll propagate down to all the groups. So I can save myself a lot of work if I do it that way. But of course, any specific information like the neighbors, the families, the types, you want to be in a group so that it doesn't, so that you can have configurations of BGP that include multiple types, include different neighbors, include different families, without having to completely redo your configuration. So it looks like we did not define the autonomous system. So that's the next step. Kind of got ahead of myself there. And it looks like the step-by-step procedure is wrong. This actually needs to come first before you can commit this. I don't think it's worth a downvote though. So let's just keep working. And I will set the autonomous system and then go back and do this one. Yeah, and you can see it's not that they just want you to look over the configuration before committing it, because they included this configuration keyword here. They want you to do it in privilege mode instead of config mode. So you could do this, but you would have to leave out the configuration keyword. So it would be show protocols BGP. That's, I think, what they were getting at. But that's, as I said, not worth a downvote. Let's keep going. Okay, so there's the autonomous system. It's in kind of a weird syntax I'm not used to seeing, but as long as it commits, it's fine by me. Yep, so for me, I'm more used to seeing an autonomous system being like a 4-byte value. Actually, yeah. So let's expand this out because it looks like it's got a good explanation of that syntax that I'm not used to. So autonomous system number in plain number or higher 16 bits dot lower 16 bits. So they're using this notation because they want the extended autonomous system number that has 32 bits separated by a dot instead of just the regular old one. Yeah. All right, so let's commit that and move on. Okay, and let's go back and do the, well, actually we don't need to go back and do the verification step they have here because we already did that without the configuration keyword. But we will need to configure these other routers to have an autonomous system. And it will need to, of course, match the P router because they are internal connections. All right, so everything's good here. Skip this, it's just to show the configuration, but it's simple enough. On the PE routers, configure BGP for VPN. Configure the local address as the local LO0.0 address. The neighbor addresses are the LO0.0 addresses of router P and the other PE router PE2. So you'll notice kind of noticeably absent from this configuration here are the other PEs. Well, that's because for the P router, we can have just the pure plain BGP configuration because it just moves route through the network. but we can't have that pure plane configuration for the PEs because, as I said, it's entry point, so we've got to handle the routes being sent through the front door and out the back door, and we've got to let them know that they're a part of whatever. So it needs to be included within it needs to be a part of a VPN, which I actually don't see here. Like this isn't right. But whatever, I'll follow the example. Hopefully it's me and not them. But I have a feeling it's them because this configuration needs to be here. All right, but let's just try it. And if it doesn't lead anywhere, we can always submit a downvote with an explanation about why it is incorrect. Okay, so everything looks good to me. Commit and quit. Hopefully there's no issues. If there are, though, one thing I really like about Juniper are those really clear messages when thing goes wrong. All right, so we've got PE2. Okay, and then we can do the show BGP group command as a verification. And at this point, we should have some neighbors. So, oh, but we don't have any established. So it looks like there is going to be a problem. Well, so we do have one in established now. And we have two in established. So let's do a show BGP neighbors. All right, let's do a show BGP summary. Okay, so we've got both our neighbors in established mode. That's interesting that there's. Okay, well, I think we're good to go. Let's continue on with the example. On the PE routers, configure a policy to export the BGP routes into OSPF. All right. Oops, and it looks like I did it on router 2 instead of router 1, but the good news is it's the same configuration, so no harm, no foul. All right, so let's do the verification command. Show policy BGP to OSPF. So yep, everything looks pretty good. From proto BGP, then accept. Yeah, I like that show policy command. I haven't seen that one before. Next step is configuring RSVP. On the PE routers, enable RSVP on the interfaces that participate in the LSP. Configure the fast Ethernet and ATM logical interfaces. So yep, configuring RSVP, configuring MPLS is really just as simple as adding the interfaces to the protocols. Really not difficult at all. As far as I know, you don't have to generally include the loopback addresses. And the other thing I kind of am curious about is they're adding, let me see here. So, oops, I don't have it anymore. Here we go. So they're adding this interface to RSVP, but I don't think that's correct because it's going to be part of a L3 VPN, so you can't just add that interface. You've got to add it to the L3 VPN RSVP configuration. So I think there's going to be issues, and I reported these in the documentation before, but it looks like I did get an email saying that they fixed up the documentation, but they must have. Well, I wouldn't have expected them actually to review all of the configuration, just the suggestions I submitted. But it looks like the errors I found are persistent across all documentation. So I don't know if it's just an out-of-date version that these are written for where it is valid, but in the routers I'm using and probably on the testing routers as well, I really think this example doesn't show me the whole picture, and in fact is not possible. Okay, so now we can do, it's just a show configuration command. Do those all the time, so it's nothing new for me. Yep, and it looks like everything is good to go. So the next step is to configure MPLS. On the PE routers, configure an MPLS LSP to the PE router. That is the LSP egress point. Specify the IP address of the LO0.0 interface on the router at the other end of the LSP. Configure MPLS on the ATM, Fast Ethernet, and LO0.0 interfaces to help identify each LSP when troubleshooting. Configure a different LSP name on each PE router. In this example, we use the name 2-PE2 as the name for the LSP configured on PE1 and 2-PE1 as the name for the LSP configured on PE2. Okay, so this might be where I leave off. I can go all the way to 1 today because I don't have a meeting, but I definitely do not want to abandon my post, so I will keep. So I will end this right at 1 at the latest. So this is another thing that I think will be a problem because it's meant to be part of a L3 VPN, so you wouldn't be adding the customer-facing interfaces just like this to the protocols MPLS that are just in the default tables. You would add them to the custom tables belonging to the L3 VPN. So I think there's going to be issues with this, but that's, I think, part of the fun. So we'll just continue on and face those issues when we get there, which will be in the afterwork video. Assuming I get that far, hopefully I will. So yep, I'll just configure the PE2, and then that will be the end of this video. Okay, so that's the end of the video. We'll just do the final verification steps if there's anything interesting. Yeah, so this looks interesting. Let's do this. Oh, label switch path not found, or no route installed. So yeah, there's no, well, I guess I was expecting a route to be installed. So I think the reason there's no, yeah, so the route wouldn't be operational yet because the P routers weren't set up. I wish I had time to do that and see this working, but I'm kind of upset that they show this here and then don't have it work like that. But I don't think it's worth a downvote. I'll show you in the afterwork video where I add these P interfaces, run this command again, and see that the MPLS LSPs are operational. So thanks for watching, and I'll see you in the next one.